Okay, so we're going to have a look at how to add and subtract fractions. This can be a level 6 topic in the UK, so what we're going to do is going to start off with one of the very simple ones that you probably do and then sort of move on up and start looking at some of the harder ones. So some of the basic ones would look like this, so 4/7 plus 2/7, and it is an easy one to do if you sort of think about it, and a diagram can often help out. So below I've got a rectangle, split it into sevens. And so 4/7, if you were to colour it in, you'd end up having 4 of them coloured in. And so that represents 4/7, and then if we add 2 more sevenths to it, if we colour in 2 more, we'll end up with a diagram that looks like this. And if we write this as a fraction at the end, then we'll get 6/7 as our answer. So this is a very straightforward kind of problem, and then you can start to see you won't need the diagram at all. You can just look at the numerators, 4 and 2, and add them, and the denominator just stays the same, so you just stay with 7. If it was a subtraction problem, you just do the same thing except take away the numerator, so you don't have to worry about anything too different. Now the tricky thing will come when you kind of end up with a fraction problem like this, where the denominators are not the same. Okay, you've got 5 and 3, and you're sort of going to get this as a common answer, that people are just going to say, well, 2 add 1 is 3 and 5 add 3 is 8, so I get 3/8. There's a number of ways you can show that that doesn't work. You can sort of think, well, if I had a half plus a half and I followed that rule, I'd end up with 2/4, which is a half, and it starts to not make sense. So we've got to find a different way of doing that. So we've got to get that answer out of the way, and we've got to start thinking about what are we going to do in order to get our answer for this one. So the first thing you've got to do is look at those denominators, and you've got to start thinking, well, they're different, and the only way we can add them is when they're the same. So what you need to do is somewhere or other get those denominators to be the same as each other. And this is done, some people will say, well, just multiply the two, that will give you 15. It doesn't really explain it, but it will get you there. And it's not always the best way. The actual best way is to find the lowest common multiple of the two, the smallest number that's in the 5 and the 3 times table. So if you was to look at 5 times table and 3 times table, the first number you're going to get to is 15. And so you'll end up with something that looks more like this as a diagram. If I start shading in 2/5, if I look at the fifths as in columns, so 2/5 there, and then keep going, I'll end up with 6/15. Okay, and do the same thing with the third. So for every 3 I colour in 1, my diagram will look like this, so I end up with 5/15. And so now rewrite the problem using those fractions instead of the previous ones you had, and then you'll be able to do it just like before. You'll end up, you can think about your diagram, shading in, and then you'll end up with your final answer of 11/15. If it's possible at the end, you might have to simplify. So you might have to cancel down the fraction to its simplest terms, looking for common factors and stuff like that if you've already done it. Otherwise, just leave it as it is. So just summing up the kind of key things we're looking at there, make sure your denominators are the same, using equivalent fractions or finding the lowest common multiple, whichever way you found most useful. Subtraction is very similar. You just do the exact same method. You just must make sure you subtract the numerators at the end. You don't have to change what you do. Treat it as if it was an add sign, and then at the end subtract, and simplify answers where possible. Now hopefully you found that video useful, and you'll look at some of the other ones I've done.